Hello, boys and girls. Today we're going to look at estimation. So, our lesson today is on estimation, and we're going to look at several different ways to estimate. One way to estimate is called front end estimation, and it is very sloppy, and I don't recommend using it very often. I will show you how to do it, and sometimes they do that in this math book, but we're mostly going to use the second way of estimating, which is called rounding. So let's look at front end estimation. Let's say I have a number that looks like this. I have 196, and I'm going to add to that 329, right? So I'm adding these numbers together. I can use front end estimation, which means I just look at the number that's in the hundreds place and I keep that same number in the hundreds place and I fill in with zeros. So this number, since I have a 3 in the hundreds place, I would just leave the 3 and I would replace the rest with zeros. So you can see that there would be a bit of a problem with this because it's going to be off by quite a bit. 100 is not super close to 196. 329 is a little bit closer to 300. So front-end estimation isn't always the most effective tool. I'll show you one more example of how to do front end. So in your math book, there's going to be a problem where we do front end. And let's look at that problem. If we look at 7,840 and we subtract 3,622 from that, we're going to use front end estimation to estimate, to check if our answer is reasonable. Okay. So if I went ahead and did this subtraction problem and I got this as my answer once I was done regrouping, we can use front end estimation to check. So in this case, my front end is 7,000. So I'm going to take this and I'm going to say that it's 7,000. In this case, my front end is a 3. It's in the thousands place, so it's going to be 3,000. Now, if I subtracted those numbers, I would get 4,000, right? So this answer is reasonable, and reasonable is the word that we use in math when an answer is close, right? So 4,000 is a reasonable front-end estimation for our actual answer, which was 4,218. Most of the time, front-end estimation is not super effective. There are a few cases when it is handy to use it, and most of the time, rounding is a little bit more effective. So, let's look at a couple of problems where we use rounding. Now, I was never very good at rounding, but I had a teacher's aide in my classroom my first year teaching, and she taught us a trick, and I call it the Poppelmeyer trick because her name is Mrs. Poppelmeyer. And so I'm going to show you the Poppelmeyer trick, okay? Let's say that I have some numbers, and the numbers look like this. Let's say that I have a number that looks like this, 196. And I want to round that number, and I want to round it to the nearest tens place. I'm going to underline the number that's in the tens place, and then I'm going to put a box around the neighbor. And I'm looking at the neighbor that is of lower place value. If this number is 5 or above, if it's 5 or greater than 5, then I'm going to put a little arrow and I'm going to add 1. That's going to change this number to a 10, and it's going to change this to a 2, and so it's going to round up to 200. Let's do another one just for practice. Let's say that I have 127 and I want to round to the nearest tens place. This is the tens place, so I put a line under the tens place. I put a box around my neighbor. My neighbor is in the ones place. This is not my neighbor. The number with the lower place value is my neighbor. So if I'm looking at a 7 and I said that if the number in the box is 5 or greater, I'm going to add 1 to this number that's underlined. This becomes a 3. The box becomes my hero 0, and this number stays the same. So if I'm rounding, 127 is really close to 130, right? That's a good estimate because we rounded it. Let's look at another number. Let's look at 122. And let's say that we want to round to, again, to the nearest 10. I put a box around my neighbor of lower place value. This is less than 5. That means that this number stays the same. So I'm going to leave the 2 here. Whatever is in the box becomes my hero 0. This number stays the same. So my estimate is 120. When we're rounding, we want to look at 5 as our middle number. If I have 0 to 10, 5 is my middle number. If it's less than 5, we're going to round down. If it's greater than 5, we round up, right? If it's 5 or above, we round up. In this case, the number in the box was a 2, so we rounded down. So we rounded down to 120. Let me show you one more with using Mrs. Poppelmeyer's trick. Let's say I have 245 and I want to round to the nearest hundreds place. So I underline the number that's in the hundreds place. I put a box around my neighbor. This time my neighbor's less than 5. So this number is not going to change. I'm not going to add 1 to it. It's going to stay the same. The box becomes my hero 0. And this number is also going to become a 0 because rounding is all about using nice, clean zeros to make it really easy. So this number, if I'm rounding to the nearest hundreds place, rounds down to 200. Now if I were to look at, let's double check by making a number line. Let's say I had 100 and then I had 200 over here. And then I had, let's make it a little smaller, I had 200 here, and then I have 300 here. So if I have 245, 250 would be right in the middle. 150 would be right in the middle here. So 245 is going to be right here. Is that closer to 200 or 300? And it's closer to 200, right? Let's do one more. Let's say I had the number, we'll keep it really simple. Let's say I had 52. And I wanted to round to the nearest tens place. I put a line under the place value that we're rounding it to. Box around my neighbor. If the box is 5 or above, then I'm going to add 1. However, this box is not 5 or above, it's less. So this 5 stays the same. The box becomes my hero 0, and we're rounding to 50, down to 50, right? Okay, now let's put a little bit of that into practice. So now that you've learned how to do that, we're going to put a little bit of it into practice. So I'm going to take a piece of paper. We're going to do some problems together that are in the book. So I'm turned to page 44 in the book. I'm going to fold my paper with 3 hamburgers, right? Hamburger, hamburger, hamburger. So we're going to look on page 45, and we're going to do the first problem that's on 45. So I'm just going to go ahead and put my lines in. You don't have to do this, but I'm doing it so that you can see my paper and so you can see my work. I'm also going to do the back side while I'm at it because I have a feeling we're going to be using the back side of the paper. Okay, so let's go ahead and I'm going to write my name. I'm going to write on here lesson number 2.1. And we're going to be working on pages 44 through 49. And so if we're looking at, we have number 1, we have all the way through 8. Okay, so we're going to go all the way to 8. Okay, so let's look at number 1 in our math book. So my math book looks just like your math book. We have the little girl wearing the blue shirt, and she's saying, she's taken 2 numbers and she's looking at her estimate, and she's saying, if I'm rounding to the nearest 100, 196 is going to round to 200, 389 is going to round up to 400, and my answer, 200 plus 400, is 600, and this answer is pretty close to 600. So it's asking, is this reasonable? Is 585 a reasonable sum? And the answer is yes. It is reasonable. 585 is pretty close to 600. Now what we're going to do is we're going to find the difference. So we're going to subtract these numbers on number 1, and then we're going to use rounding to check if it's reasonable. We're going to round each number to the nearest 100. So it's asking us to do rounding to the nearest 100. So here's our problem to start out with. We have 786, and we're subtracting 453. So we're going to go ahead and do the problem first. 6 minus 3 is 3. 8 minus 5 is 3. And 7 minus 4 is 3. So it's 333 is our answer. Now, we're going to go ahead and figure out, we're going to round to check to see if the answer is reasonable. So we're going to figure out, and they told us we're rounding to the nearest 100. So we're going to take 786. We're going to round it to the nearest 100. So this is the hundreds place. Here's my neighbor. I put a box around the neighbor. I'm just enlarging this a little teensy bit. I don't worry about the 6. I only worry about what's in the box. If this is 5 or above, I'm going to add 1. This becomes 8. This becomes my hero, 0. And this also becomes 0. So we're saying if we round to the nearest 100 that 786 is closest to 800. So I'm going to write 800 right next to this one. Now, I'm going to just put this off to the side, and we're going to look at 453. If I'm rounding to the nearest 100, the 4 is in the hundreds place. So I underline that 4. I'm going to put a box around my neighbor. Is my neighbor 5 or above? And the answer is yes, it's 5. So that means I'm going to add 1 to this number that's underlined, that's in the hundreds place. 4 plus 1 is 5. My box becomes my hero 0. And also the 3, we want it to be a nice, neat, even number with zeros if possible. So that means that this number is 500. Now, is my answer reasonable when I subtract? Is it close to 333? And the answer is yes. It is reasonable. And I know it's reasonable because it's close, right? So yes, it's reasonable. That was pretty easy. When you're using rounding, you're going to get an answer that is pretty close. Now we're going to do a problem where we use front-end estimation, okay? So we're going to use our trick, and in your math book it explains, just like I explained to you earlier, front-end estimation, you take the front number, 7,840 just becomes 7,000. 3,622 just becomes 3,000. Whatever number is in the front is the number you go with, and the rest of the numbers become zeros. Sometimes this is not super accurate. In this case, it's probably not going to be super accurate because we're dealing with thousands, right? So we're going to be off by a lot more. So let's look at number 2. This time we're going to use front-end estimation for number 2. So we're going to take 6,000, and I might turn my paper so I have a little bit more room. I'm going to take 6,572, and I'm going to add to that 8,144. And when I add those together, if I stacked them over here, I would get if I add them together, I'm going to get 4 plus 2 is 6, 7 plus 4 is 11, 5, 6, 7, and this is 14, right? So I end up getting 14,716 as my answer. Now let's use front-end estimation to estimate this problem. That means that this is going to become 6,000, and this becomes 8,000. And when I add those together, they're going to be 14,000. Now, 14,000, is it close to 14,716? It's off by 700, right? So I'm not sure it is reasonable. I mean, they both start with 14, right? So we could say the number is not as reasonable if I rounded it would be closer. So front-end estimation is just really quick, and it's not always super accurate. I mean, we're off by 700. So I would not say that that's super reasonable. If you were doing this and instead of 6,572, if you just had 72 and you just had 44, and you made this 70 and you made that 40, it would be a lot closer. But the larger your numbers get, the less reasonable front-end estimation gets. Okay? Let's look at number 3. Number 3 says find each sum or difference and then use rounding or front-end estimation to check that your answers are reasonable. Round each number to the nearest hundred. So these are all numbers that are in the thousands. I'm going to use rounding instead of front end. Maybe we'll do rounding, 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 or let's do front end, then rounding, rounding, rounding. Okay? So that you really get some practice rounding, because I'm not sure that the front end dealing with numbers that are in the thousands place is going to be that effective. So let's go ahead and add our numbers together. We have 5,426, and we're adding to that 3,210. When we add them together, we get 6, 3, 6, 8, right? So we get 8,636. Now, if I'm using front-end estimation to do this, I'm going to take this 5 and I'm going to put it over here, and it's going to be 5,000, right? I'm going to take this 3 that's in the thousands place, and I'm going to bring it over here, and it's going to be 3,000. When I add those together, I'm going to get 8,000. Is it reasonable? Well, we're off by 600. It's probably close enough, but it's not as reasonable as if we rounded. So we're still in the same thousands place, but we're off by about 600. So we could say, yes, it's reasonable. However, it would be more reasonable if we rounded. So the next one we're going to round, okay? I'm going to keep it going, my paper going this way, because I need it to be a little bit wider. So this time I'm going to subtract. It's asking us to take two numbers and subtract them. Now that we're excellent subtractors. So we're looking at this first number, 5 minus 6. We can't do that. That's not going to work, right? Oops, too big. Sorry. I was trying to get clever and do a close-up, and there we go. So if I subtract this, I can't. I have to regroup, right? So I'm going to cash in. This becomes 6. This becomes 15. This becomes 9. This becomes 1. This becomes 1. This becomes 5. So when I subtract, I get 5,119. Now we're going to look, and we're going to round these numbers, and we're going to round to the nearest 100 because that's what it told us to do. So if I look at this number, here's the hundreds place. Here's my neighbor in the box. I want the next lowest place value to the place we're underlining. This is a 7. It's greater than 5. So that means I'm going to add 1 to the underlined 4. This becomes 5. The box becomes my hero, 0. This becomes a 0. And the 8,000 stays the same, right? Let's try this number right here. Now we have 3,356. We're rounding to the nearest 100. Box goes on the neighbor with the lower place value. This 5, it's 5 or above, so I'm going to add 1 to it. This 3 in the hundreds place becomes a 4. The box becomes my hero, 0. The 6 also becomes a 0. And the 3 in the thousands place stays the same. Now, let's see if it's reasonable. We're going to take this number on the top and this number on the bottom. And we're going to subtract them. And part of the reason why we do rounding and as estimation is so that it's easier to subtract. Look, we have 0 minus 0 is 0. So look at how close our answer was when we were doing rounding, when we rounded to the nearest hundred. If we were to use front-end estimation, this would be 8,000 minus 3,000, and that would give us 5,000. So we'd be off by 100. So when we're using rounding, rounding gets us a little bit more of an accurate estimate instead of front-end estimation. Okay, let's look at number 5. This time we have 9,633, and we're adding 4,250. So we're adding those together, and we get 13,883 when we add them. Now what we're going to do is we're going to use rounding to figure out if our answer is reasonable, if it's accurate. So let's first round this number. It told us we had to round to the nearest hundred, so the 6 is in the hundreds place. My neighbor in the lower place value is a 3, so I put a box around my neighbor. If this is less than 5, this stays the same. The box becomes my hero, 0. This number also becomes a 0. This number stays the same. Okay, so I have 9,600. Let's take this number over here and round it. Again, we're rounding to the nearest hundred because that's what it told us to do. Box goes around my neighbor with the lower place value. This has a 5 in the box, so I'm going to add 1. If it's 5 or greater, we add 1. This 2 becomes a 3. The box becomes my hero, 0. This becomes a 0. And the 4 stays the same. So if I add these two together, let's just bring this on over and we'll add it. We'll see if it's reasonable, if it's close to this. So is it reasonable? Absolutely. Look, we're only off by 20, right? Roughly 20, even less than that. So we're going to say yes, it's reasonable. We're going to say yes, it was reasonable-ish on that one. And then let's look at number 6, our last one. This one is a bigger problem, and because it has larger numbers, I'm not going to use front end. I don't like using front end when I have lots of place value to deal with because it's not very accurate. So if I subtracted this and I wanted to see if my answer was reasonable, I would go ahead and subtract. It's a nice, easy subtraction problem. I get 4,311. I had to do almost no regrouping, so that's good. Now, if I want to use front end on this, if I use front end estimation on this, the 1 would stay the same and it would be 10,000. The 1 would stay the same and it would be 10,000. So my answer would be 0. Is that a reasonable answer? No. And that's why I like to use rounding. So it asked us to round to the hundreds place. So we're going to round 16,862. Here's the hundreds place. Here's my neighbor. Inside the box, it's a 6. That means we're going to add 1 to that 8 in the hundreds place. So that is going to be 9. The box becomes my hero, 0. The 2 becomes a 0. And the other two numbers just stay the same, right? Now, here's our other number. We have 12,551. Here's my hundreds place. Here's my neighbor. This is 5 or above, so I add 1 to it. This 5 in the hundreds place becomes a 6. The box becomes my hero, 0. And this number also becomes a 0. And the 1 and the 2 stay the same. So which one's more reasonable, 0 or 4,300, right? And this is one of the reasons why using rounding just seems to work a little bit better, especially when you're dealing with larger numbers. So we're going to say, yes, it's reasonable, right? It was reasonable when we rounded. It was unreasonable when we used front-end estimation. Okay? Now, your math book starts talking about multiplication. And there's really not a huge difference between rounding, no matter what procedure you're using, right? Or what process you're using. So we have a word problem right here. It says Santos bought 2 cartons of single cup coffee pods, each containing 326 coffee pods. Find the total number of coffee pods in the cartons. So we're going to use multiplication. 326 pods times 2 cartons equals 652. Now we can use an estimate. You could use front end, right? Or you could round it. We're rounding it to the nearest hundred, so it's going to be 300 times 2 is 600, right? So 600 is pretty close to 652. Multiplication it's a little bit trickier to estimate because when you multiply numbers, they get bigger fast. So I would say 600 is a reasonable answer to 652. They're close. Now we're going to do our problem on our page together. We're going to do rounding on number 7 to find the product. So on number 7, it's telling us that we have 242 times 4. So when we actually multiply 242 times 4, we get 968, right? So if I'm estimating and I'm rounding to the nearest hundred and I have 242 and here's the nearest hundred, I underline the number in the hundreds place. My neighbor with the lower place value becomes the box. And I have less than 5, so this number is going to stay the same. My box becomes my hero, 0. This number becomes a 0. So if I multiply 200 times 4, I get 800, right? Is that reasonable? I would say it is reasonable, right? It's reasonable because in multiplication, you end up accepting a lot closer answer, right? Or a lot further apart answer differences between the two when you're multiplying, because when you multiply, numbers become a lot greater fast. So I would say that actually is reasonable. If you were adding numbers and if you were 168 apart and adding, I would say no, probably not reasonable. But for multiplication, that's actually pretty close. I've seen worse. Now we're going to do front end. On number 8, we're going to do front end. And you're going to see that if front end works well for multiplication. So I'm looking to find, it says I'm looking at 471 times 2. So if I really multiply 471 times 2, I get 942. Now, if I want to look and I want to round, I want to use front end, I'm going to look at this 4 on 471, and I'm going to say, oh, that's close to 400, right? I only look at the front number, and the rest becomes zeros. And when I multiply 400 times 2, I get 800. Is 942 and 800, is that reasonable? I would say maybe not quite as reasonable as when we rounded it, right? Rounding is a lot more precise and a lot more accurate than using front-end estimation. And you might ask yourself then, why are we learning front-end estimation if it's so lazy and sloppy and if it doesn't get us as close? And the answer is because sometimes you're in a hurry and the box and the neighbor takes too long. Let's say I'm in the grocery store and I'm buying groceries and I want to get a quick estimate to see if I have enough money. I'm probably not going to sit down with a piece of paper and make boxes and neighbors, right? But I might say, that's close to $2. That's close to $4. I have $10. That'll be okay because that's $6 and I have enough money. So sometimes we use front-end estimation when we're shopping. We might use it in other, like if we're running a race and we need quick results. Anytime you need something that's fast and kind of a little sloppy, and it doesn't matter if it's super accurate, then you can use front end. For most of our purposes when we're doing math, we're going to use rounding because rounding is a little bit more precise. Okay, so I'm going to show you one more time the Mrs. Poppelmeyer trick. We'll use an easy sample number. Let's say we have 84. And we want to round to the nearest tens place. We underline the number in the tens place. This number, the next lowest place value, becomes the box. If the box has 5 or higher, this number is going to go up by 1. In this case, it's less than 5, so this number stays the same. The box always becomes my hero, 0. So in this case, if I'm looking at a number that's between 80 and 90, 85 is the number in the middle, right? If I have 84, it's closer to 80. Not closer to 90, closer to 80. Sometimes you can draw yourself a picture if you're trying to figure out rounding fast. I just find that the Mrs. Poppelmeyer trick works really quickly to give me a rounded answer. So I hope it works well for you. And I hope this lesson helped you understand rounding and also front-end estimation. It's important to be able to estimate with front-end really quickly, but it's also, I think, even more important to be able to do more precise rounding. All right, we will say goodbye for now, and we'll see you next time. Thanks.